But let's start with officially the first lecture of this course. So welcome to software maintenance course. This is the first one of the 10 lectures we are having on this course, because the latter part of the course is meant for your independent work and your seminar presentations and studying how software maintenance happens in real life. So, the course name, software maintenance, of course means that we have to do something with real existing code. So unlike many of the other courses on the master's degree program, on this course you are actually expected to do some programming work. You are expected to take an open source repository, clone it for yourself. Let's not for teaching purposes harass any open source projects. Take your own copy or own branch of a project, and then you are expected to do some maintenance work on it. At the same time, we will be talking about issues, aspects of what to do with the legacy software, how to manage maintaining existing code base, how to add features to software, what sort of tools we have, what can we do if we, for some reason, manage to lose our entire source code base, or need to dig out information from some old bank, insurance company, industrial automation system, which anyone who was actually involved with building of the software has been retired for the last 20 years, and we need to figure out how it actually works and how it can be updated. So these are all the stuff that we are covering on this course. This is directly from the study guide, and it, in a few bullet points, gives the idea on what we are doing on this course. So work as a software developer with an existing code base. So you have been studying for 3 years now, and 3.5 years. Probably most of you have some industry experience, or at least some professional software development experience. So on this course, you are treated, or at least expected, to be able to function as some form of software developer. Also, you will get the best practices, or the theory on best practices on how to do maintenance work, how to do automation, how to manage technical debt, what are code standards, refactoring, design patterns, what sort of things are involved when we try to either maintain or improve upon existing code base. Also, what software evolution is and how to reuse existing components, or do re-engineering work or reverse engineering work if we need to figure out what happens within one module which we no longer can look into, meaning that we don't have the source code available. What sort of tools there are to try to decompile, for example, Java code. There are several of them, some good, some bad, some even worse, but still there's tools that exist to help you to get some sort of an idea out from how system works. So this is more or less list of the lectures we are going to have on this course. Today we are here on Tuesday. On upcoming 9 weeks we will be meeting on Monday. As always, of course, these lectures are voluntary, so if you have something better to do, then by all means go there where you are needed or expected to be. But anyway, we will be going through all these topics one per week, and there will be exercises. There will be a possibility to ask questions. I have a consulting hour immediate following on the afternoon following the lecture. So if you happen to be here on Monday, you can get local support if you are somewhere else, or if you are participating via online, meaning that I'm more or less now talking to the recorder, You can put your questions to the Moodle pages. I will be at least once per week, several times per week, most likely, browsing through them and seeing that everyone gets at least some answer before the next weekly deadline. Of course, this being a master's level course, I will not be holding your hand, so I will not show step by step how to decompile Python or Java code. I'm expecting you to be able to find the tools, use them, get a sort of an answer independently. Of course, I can give you some pointers on how to get started. Similarly as with the exercises, if we are talking about containers and how to create them, obviously I'm not going to show you step by step how to complete the tutorials and do a compiler setup or container setup on your build system. But of course there's tutorials which I will be pointing you towards that you should be doing. Anyway, software quality in use, measurements, how to actually understand what is going on, how regression testing affects things, what is code smell, reverse engineering, software product lines, development during maintenance, maintenance tools, software aging, how legacy systems are in general supported, or other way around, on the flip side of the coin, how can we decide what's enough software maintenance, what's enough support. The last step of the support is the end of the life cycle. So we take our software product and put a bullet in its head. That's also something that we need to make the decision on. What's too much, what's the point on which there's no reason to continue working. So on this course, there are several things you need to do. Some say that this course is a bit laborious, perhaps, but still it's something that's really, well, the feedback has said that there's actually several good things which explain things on practical level. First of all, there's project work and seminar work on software maintenance. When you get access to Moodle, all the instructions are already online, so you can start working on these immediately. On the project, you are expected to, the first project you are expected to do simple maintenance cycle and design a maintenance infrastructure for existing open source product game 0AD. On the project 2, you are expected to, with your group, get familiar with some other open source project and do software development on that product. For example, pick on text editor software and make a new feature, add new features on it, or fix something from PDF printer, or take some browser and add new functionalities, hotkeys, that sort of stuff. The small things that you would probably be expected to do when and if you are hired to do software maintenance work as a real-life developer. So you are given a product, you will be babysitting, and there will be tickets and additions and stuff, which you are required to do. We will try to arrange a visiting lecturer, someone who actually works with the legacy software or has long time running software products or product lines, tell about how this differs from other fields of software engineering, or what are the most important or biggest problems in software maintenance work. Unfortunately, I cannot guarantee that you will have one, but if the visiting lecturer has cancelled at the last minute, like last year, then we will look some other options. But we are intended to have a visiting lecturer on this course. There's also a couple of books and standardizations which can be used as added or extra materials if you want to watch or read them through. At least the standardization paper is on the Moodle pages. So there's an extra reading library or something like that link on the first part of the pages. There's several PDFs which includes all the things that we are discussing here about how to define quality, how to define measurements, what measurements there exists, and of course also this software lifecycle processes and maintenance activities are also there. There's also some other materials available via that link, but you can browse it at your own leisure when you get access to the Moodle pages. Anyway, the first part, the first 7 weeks are more or less traditional course. Once per week we have a lecture followed by weekly assignments. Usually you have two options: practical work where you have to code something or create something, or theoretical work where you are expected to write a technical essay about certain topic, discussing the weekly topic of the lecture. For the fourth period, the last 7 weeks, we will be also having the lectures on the first part, but then we will also have the online seminars, and you need to turn in the project works. I would hardly recommend that you start the projects before the fourth period, because they might need some work, and also because they are not something that you can just hack together within the last weekend or so. So please create a group and start working them early on. Anyway, for the online seminars, you are expected to also make a video. Your presentation will be put online, or well, you are putting it online, so that if we have students who are participating long distance, they can also see your presentations. Also, because last year we were doing this as a traditional seminar, we ran out of time, and it was a sort of a hassle, so that's why we are using the online version this year. If you are worried about your voice or even face being on a video on internet, you can take the video offline and as soon as the course ends, but let's do it as an online seminars because it's more convenient for you all, because it also means that there will be no 3-4 hour marathon sessions on these seminar presentations. Anyway, the instructions will be on the Moodle pages when they are available for you. And unlike some other courses, this course basically grades or gives parts of the grade from almost everything. You have the weekly assignments. There's a mandatory minimum of 4 assignments. I think it translates to something like 35% of the assignments, so at least complete number of those. There's also teamwork project, which is the project 1, online exam, and final project or the presentation seminar project, which is the project 2. Important part here to understand is that the online exam is only 20% of the grade. The most important, you need to get at least 1 point from all categories and more than half of the points available to get a passing grade. It's not a problem usually, but you need to understand that you have to do all the 4 parts on the 1 year or during this spring to get the passing grade. Anyway, none of these parts are so superior to anything else that you can just do as backwards work on everything else and focus on one thing. This also, of course, means that if you have problems with one assignment, it doesn't completely ruin your final grade at the end. So each week, like mentioned, during the lectures, starting from next week up until the week 10, you will have weekly assignments. You will the assignment opens immediately following the lecture, and you will have until the next lecture to submit your work. You can select which one of the works or given assignments you prefer and submit that. And you need to do 4 accepted submissions so that you will get the 1 point for the weekly assignments. And of course, if you turn in more, then you will get more points, and so on and so on. So you can more or less manage what you want to do. Most weekly assignments involve a theoretical option and technical option, sometimes even more. And if you want to stop or doing this, or you have something more pressing to do, then you only need to turn in the first 4 weekly assignments. Of course, nice thing about this is that these also introduce you to several of the tools and techniques and technologies involved in software maintenance work. So these might be good things for you even from the professional point of view, especially if you haven't been working as a software developer in a larger context before taking this course. And so that this is clear to everyone, we do not have separate exercise events on this course. On some materials, there are mentions of exercise groups, or that there used to be something like this. This year's course does not have exercise events. Everything will be online. If you have problems, put ticket to Moodle or add your question there. Or if it's more larger problems, if you need to submit your example code or screen capture images or stuff like that, then you can use your email. But in general, you can receive help and ask for help via Moodle pages. You can also talk with me after the lectures. The lectures are on Monday from 10 to 12. So I go have a lunch so that I'm not as angry as usual anymore about 1 p.m. and then you can come in and ask questions. I'll be at my office, or if you have something immediately important, you can ask right after the lecture. But if there are exercise events marked somewhere, then these events doesn't exist. Well, you can go there, but I will not be available there. We tried having exercise groups for this, and I think the average amount of participants were 0.01 student per event, so we decided that we will no longer arrange them separately. You can ask for help via email, because that's more convenient for all of us. Okay, so the projects. The first one is called Teamwork Project. This is a technical challenge. This is something that's intended to be done on the first part of the course. Of course, if you don't have prior experience on software development work, this might come as a bit of a challenging work, so that's why I'm not limiting the deadline that much. Basically, the idea is that you are with a group of maximum of 3 students, the new person maintaining open source strategy game 0AD. It's a bit like Age of Empires 2 game. And the idea is that you are, playing as a software maintenance team for the game. So branch your own version of the game. You need to do testing work. You need to do bug fixes. If you find any problems, then fix them. You can do further development, add units, add translations, stuff like that. The scoring sheet is on the course pages. Select enough points so that you get the grade you want to get. And of course, if you want to work in teams, you might be interested in seeing what the requirements are. Also, the same theme will be on the seminar presentation. So if someone drops out from the course, before turning into all the projects, then it's up to your project team to manage the loss of personnel. But meaning that if you should probably consider who you want to work with based on this, on the fact that you have to keep working with the same team throughout the course. Anyway, develop new features, do some maintenance work, create an infrastructure for maintaining the product or running test versions or doing test automation or stuff like that. You don't obviously have to do complete unit test automation for the project. It would take hundreds of man hours, and obviously that would be completely freaking insane. So just create an infrastructure on which you could start doing automated testing and stuff like that. And version control, and add new features to your game, translations, new units, new countries, new graphical assets, animations, or fix problems from the existing game. Fairly simple stuff. And this is immediately available, so found a group and start looking through the instructions online. The second the online exam, which is also 20% of the final grade, similarly as the project one, is going to be an online exam. It means that there's a link and on the course pages which comes active sometime during later part of this course. I haven't decided yet. You have about a week to complete the exam. So it's 3 hours from start, essay questions, small pseudo programming assignments, maybe drawing something, and it's a take-home exam. So basically you can go home, do it on your living room, use internet, Google, Stack Overflow, whatever, to get answers to the questions. As long as you reference everything, then I don't care. But keep in mind that everyone does their own home exam, and there's enough variations. It will be assign you random assignments from a pool of similarly difficult questions, so that you can, as a course, even reserve one workstation classroom and work together if you want to. I think there's 16 million permutations of the final exam, so it's very unlikely that you will be doing the same exam, everyone. So anyway, this is something that's going to be active on the latter part of the course, and it replaces all the paper exams and stuff like that. It's just a test that you actually have read through the lectures and understand what the general topics of this course are. And then the project 2 is a extension for the project 1. So on the project 1, where you are working as a maintenance crew on 0 AD the game, on project 2 you are doing a more extended version of the same thing, but with a real live open source software project or software application or file system, whatever you want to investigate. So within your group, select one open source project. Investigate how they do software maintenance, how they do software testing, how they do quality assurance, how they do development or design on what new features or abilities are added in each branch. It has to be open source project because we don't want to support slave drives here, so it cannot be a closed source, so that your work, if you want to submit your changes or additions to the project, you are welcome to do so. And of course, I have to be able to see what you have been doing. If you are using commercial closed software, it would involve unnecessary legal agreements and secrecy stuff, IPRs and stuff like that. So we have decided that we will only allow open source projects on this course. So conduct a study on how this project is maintained, what are the most common activities, what are the most common problems, and what aspects could be improved. Also, what infrastructure, technology, tools, software, deployment systems, automation tools, other maintenance suites are used in the development of the software. And as an example, do a couple of small additions or changes to the product, showing off that your support and maintenance infrastructure actually works. Of course, this is first come, first served approach. So immediately when you get access to the Moodle pages, you can register your group and register your product or the open source project. This is important because we don't allow several groups on the same project. So only one group per application or operating system or game, and first come, first served. Register your group on the Moodle pages with email to lecture actually isn't true. There's a separate discussion forum on which you inform who are in your group, what your project will be, and based on the timestamp of that message, we will decide who was the first to reserve their project. So if you definitely want to do your examination on the open file system, OpenFS, then run the Moodle pages as fast as you can. I can assure you that some simple text editors like Atom or smaller projects tend to go fast. So if you are absolutely certain or already volunteer on some open source project and want to do your examination on that as fast as possible, register your group and then inform the rest of the course on which open source project you are doing your seminar, report, and study. And I'm not putting any restrictions here, but keep in mind that this is the largest single graded part of this course. So if you have some Python extension library, which has like 100 lines of code and it has had exactly one revision once, technically it's an open source project, so you are, yes, allowed to use that as your report, but let's say that it's not going to get very high rankings later on. So focus on something that interests you, also something that might be useful for yourself. Or if you have hobbies which include stuff or which use software, then of course it might be worthwhile to consider if you want to combine that on this examination of how open source projects are maintained and developed further after their initial release. And like on all courses, all information which is put on the Moodle page is the most up-to-date information. The notification board on the Moodle pages is the most up-to-date place for information on deadlines, further readings, or something that has been changed, for example, on the project assignments or somewhere else. If I'm saying here on the lecture something and the Moodle pages say something else, do as the Moodle pages say, because that probably means that I had to change something for practical reasons. Also keep in mind that in cases of me having to travel somewhere, I'm unable to keep the lectures. The lecture on the Moodle pages will be 2019 recording, so the administrative stuff is not up to date. But always ensure that you do as the Moodle pages say, and when the Moodle pages become online, I will send you further email so that you can ensure that you actually have access there. Everything is submitted via Moodle pages, so it's absolutely critical that each of you get access to that page. Usually the page is already available, but for some whatever reason it isn't, so let's hope that it comes online okay. And as a required disclaimer, this course requires programming knowledge. If you cannot do programming tasks with any programming language, you should reconsider enrolling to this course and take some programming courses before you start. This course may have difficult assignments, so we are aiming to get you closer to the actual software development and maintenance level. And on this course, we no longer teach you how to do for loop on Python or stuff like that. So you are expected to complete more difficult assignments. So no extensions will be given simply because you lack programming skills or stuff like that. Start earlier. Teamwork is allowed and actually even expected on this course, so teams up to 3 students can work together on the teamwork assignments. And keep in mind that you cannot change or add members after you have registered your project topic. So choose wisely. Finally, it is cheating to copy or buy your exercise or project works from the internet, from a colleague, other team, everywhere, anywhere else. Every team and student has to make their own original contributions. And we will be using random sampling on your submitted works to see and compare them against each other and works submitted last summer or last year. So do your own original work. All cases are forwarded to the faculty and will involve formal investigations, and there will be no exceptions on this rule. So do your own work. This is your one and final warning about that. Anyway, all problems, requests, questions, comments should be sent to me via email. If you need something, send me an email or visit me during consultation hours or use the Moodle pages. These are the 3 ways to contact me, and this is how everything on this course works. So, do you have anything to ask before we'll go into the actual topic of today? Yes.
So the second project where was open source, that needs to be somebody else's project, or could you just make your own project?
Well, if you are capable of doing multi-year, multi-release planning project during this course, then yes, because you probably invented a time machine, I will allow it. But otherwise, I'd say that you probably want to use something pre-existing. Small software, game, Linux application, something like that. For example, last year there was one person doing a photo editing software, investigating one photo editing software they liked very much. Firefox is also something that's usually quite popular, but the Firefox is a huge, huge project. So keep in mind that it's really complicated, it's really complex, it's full of legacy stuff. I mean, the browser is what, 20 years old or something like that. So, of course, if you take old and large project, the amount of documentation and source code will also be enormous. So you might want to consider also that factor, but it's up to your team to select what you want to do. I'm not going to restrict you too much. If you want to take the entire Linux kernel, for example, then by all means, or the X windowing system or whatever you want to do, then by all means, if you feel like it, go for it. Okay, thank you. Anything else? Good. So, this is usually the marketing speech on why this course is important. Well, of course, most of you are here because this is mandatory course for you, so there's that. But there is a reason why we have a separate course on software maintenance. On several approaches, or in several software engineering and computer science programs, the idea is that if we need something, we design something, we make a technical specification, we develop it, test it, and we take it into use. And that's the end of the story. Well, it works to some degree, but unfortunately, most of the real world doesn't work that way. The first launch, or the launch of the first version, is only the starting point of the actual real life cycle of the software. When we first give the product for someone else to use, it's the first time when we actually are having customers or users or money involved, or we are actually trying to do something professionally. If we are just digging around with our own lab-made small tools and using it to fasten some process or investigate some phenomena or whatever, that's nice, and of course it's software, but if we are doing something professional or doing software business, we need to also do software maintenance. And of course, this means that we have to do, for example, modification work. After the software has been delivered, there might be problems, we need to fix them. There might be need for changes, we need to do them. We might need to add content or add features, well, they have to be implemented. And we also need to do testing work, quality assurance, and all the necessary steps to ensure that when we leave or we give the newest patch to our users, it still works. So basically, nothing changes after the launch, except that we have a customer who is probably really impatient and wants us to fix our faulty software if we release something that's horribly programmed. Also, considering maintainability, this is a feature, or not a feature, an attribute. It's an attribute of software design. It's something that defines the ease with which a software system can be corrected. This is not something that happens by mistake or something that just emerges from doing work. This is something that you have to design for. So not only is the maintenance or maintainability something that you do after the first launch, it's something that also requires you to design things in a certain way, or at least consider the possibility that you want to expand your product, new features, new content, new maps, more different types of supported hardware platforms after the initial launch, because you don't want to do the same work again and again and again, or be in a situation where you can't release your product on a new digital platform because your system simply cannot expand to there, because your competition can. And in real life software business, it usually also means that your competition won. You failed because you didn't create a software which would be as good as your competitors. So, also, why we are having this course? It's understandable that if you want to have extendability or maintainability, you need to design for it. But for some reason, this isn't actually something that's very well supported or acknowledged in general. There's been studies on why maintenance is a problem. And surprisingly, this doesn't change much from the software engineering models and modeling course or from the first fundamentals of software engineering course. So why do we have problems doing software maintenance? The programs are not well documented. The programs are unstructured. The program does not use data models or data dictionaries or function as they are expected to work. And we cannot do maintenance on a system which was not designed for maintenance. Well, of course, you can argue about the last part, but still, they are badly documented. They are unstructured, and they are doing things they are not supposed to be doing. So basically, all the same problems of software engineering also translate to software maintenance. That's also because software maintenance is one of the steps of software engineering and software lifecycle. So obviously, the problems are the same. So why is the maintenance hard work? We cannot trace the product nor the process. We don't have access to anyone who still knows how the system was made. If you had a software engineering course given by me in the past, you know that one of the most important aspects which improves software testing practices or software quality is simple. Add your freaking name to the unit test you created or to the version history you just pushed into the repository. Because the most important problem usually with the quality assurance is that we don't know who made this code. We don't know who to ask for. And this is when we are making the first version of the software. If we are talking about something that we actually need to maintain several years after it has been first done, the person might not be in the company anymore. Heck, they might not even be alive anymore. So how can we trace who did this? How can we trace why it was done? Do we have documentation? Well, usually we don't. That's also something that needs to be done. And it doesn't mean that we need to have someone who actually just keeps writing the technical documentation. Because that's 90s, that's in the past. That's someone's crazy fever dream, having a technical writer doing all the documentation work. No, we need to have tools which create adequate trail of activities or log. Or if there's some problem, and if there's only if there is something that needs to be explained, then we write down that part. Only in some crazy space agencies or in military or aviation, there's people who start doing maintenance work by updating the UML charts. That doesn't usually happen, but still we need to have adequate documentation to understand who did, why did, and how it was done. Also, well, maintenance is hard usually because we end up at some point working with software or source code which is a bit outdated. It was built for the older versions of the libraries. It was built for something that's technical platforms that no longer are in sale. Everything that we use current day is more modern and we need to add or move stuff. So there's a change instability. If we are publishing mobile phone games, for example, the Android keeps going on. I think there's several, over 3 major updates on the Android version, officially supported versions. There's also different sizes of screens, different ways of doing input, different addition libraries everywhere. And if we are going at also PC platform, Apple products, also something else, we are having problems that everything changes constantly. And we have to try to keep up with that. how the platform develops. That's also a problem. And finally, there's a view that maintenance is just something that we do after we deliver the product. Of course, it's not only that. The documentation doesn't appear from nowhere. The infrastructure to do the maintenance cycles doesn't appear from nowhere. If we are releasing our product on several different platforms, adding more platforms or adding support for multi-platform designs doesn't appear from nowhere. We need to actually address all these problems even before we release anything. Because of course we know that if we release something for mobile phone, the product users in 5 years will be using different phones than the ones we are now using to develop the software. Of course, if we are in industrial automation or some other area, the change cycle isn't that quick, but it's still going to happen at some point. If we are using software or developing software, we need to consider that this source code, this module, might be in use for next 15, 20 years. And while it still needs to run on the last day of its existence, as long as someone is using it. So, on this course, how do we define what we are trying to maintain? Okay, so we have a software. It's made out of components or modules, whatever you want to use as your terminology, because it differs a bit between platforms and technologies. So there's several components which are interconnected. Some of them do user interface drawing. Some of them are event listeners, listening to the operating system or the touch screen or your joystick or gamepad or whatever. Some of them are for networking. Some of them are for doing complex mathematics and calculations. But anyway, you have software which is full of components which have some activities they do. Each component has objects which are source code and created via programming to do routines and manage and send messages. So far, quite simple. And finally, all these things are connected to databases, backend systems, internet, or have keyboards, input systems, output systems, mouse, heat sensors, Internet of Things, tools, whatever in them. The internet connection, whether it's a service-oriented architecture or peer-to-peer system, doesn't really matter here. But what it actually means is that we consider that the software of this course is a system. It's a functional product. It's a functional combination of different modules which might be local or non-local components. They might have hardware or not. We don't want to restrict on the theory the discussion too much about what type of software we are maintaining here. The idea is that we are doing software maintenance, whatever the system might be. And for example, if we are doing acceptance testing, we are doing something like this. So there's a system being built, there's sensors, there's client-side services, there's server cluster, cloud, databases, framework components, user interface overlay, stuff like that. So whether it's a game or application or automation tool or operating system, or whether it's an Internet of Things thing or embedded software or whatever, they all share the same features, that they have objects or components in them which exchange messages, whether it's hardware or another software component, but still the fundamental way of working is the same. And of course, because we are talking about software, we need to also do the development in one way. Basically, if we consider different types of standardizations and processes and process models and stuff like that, we come up with something like this. So we do requirements analysis and specification, and then we hit the phase where we are doing design, development, and testing quality assurance at the same time. In small iterations, whether it's Scrum approach or daily iterations, if it's an XP or something like that, we might actually even do some continuous integration, continuous delivery approaches, which of course means that immediately if the quality assurance passes, then we put it on a staging server and release it as a new version. But anyway, at some point, when we have the designs implemented and tested, whether it's the weekly or daily or the final only build, we do acceptance and put it into operations. So we put it available online for the users. And then there's the maintenance work. And finally, sometime later, the end of the support for that product. Meaning that the product no longer is viable. There's no financial or any other interest to keep the system alive. But of course, this is also something that we need to decide on. So basically, from earlier courses, this part from the requirements analysis to acceptance and operations is usually called software process. It doesn't care about the maintenance or end-of-life support. It just mentions that it happens. But of course, because we are the Department of Software Engineering, we have to also consider the software lifecycle, which is from the first ideas that this might actually work, or initial prototype, proof of concept work, from the last day when the last user is kicked out from the last remaining server, or the last user throws their old legacy phone to the lake, and there are no longer users for that particular software. So everything that happens between these stages. And of course, on our courses, most of you probably have already taken the software engineering methods and models course, probably last fall. So on this course, the idea was that we talk about requirements analysis, specifications, design, and all the way to the acceptance and operations. So how we do modeling, how we do software engineering work, what sort of methods, tools are involved there. And on this course, we continue on that topic by discussing the world where you have actually released your first product. So now it's out. What do I do now? So, of course, why? Why does this course exist? 3 years ago, there wasn't one. So why now? Well, of course, maintenance is huge amount of time on almost all software products and services. The first development iteration, the first launch, it's what, 10% of the time, something like that. We develop our product for 6 months before we put it online, and then we support it for 10 years, 5 years before we put it out of its misery, or make a sequel if it's a game and move to support that one. So of course, it's a huge amount of time. Several things will happen, especially when we add new people. Trends change, hardware changes, software changes. So how do we actually keep the system operational and do the necessary modifications to cater to our new customers, keep our existing customers, take into account the new hardware systems, stuff that didn't even exist when we launched the first version of our product. And also, if we are going to ever build anything that stays intact, we have to do maintenance work to get rid of all the bugs, problems, viruses, counter cyber threats, these sort of things. They thrill on finding abuses or problems, holes which need to be fixed, because there's always a problem somewhere. So if we find one, we need to fix them. And also, if we are updating, for example, something from our hardware platform, the operating system, the libraries, whatever updates, then we need to do the necessary things on our software. And in comparison to the first development iteration, or in general the software engineering, software maintenance is a significant portion of life cycle, and it also has a number of tools which are fairly unique to that area. Usually in tracing tools or reverse engineering tools, packet sniffers, which try to guess how the system might work, or how to recreate or untangle our object-oriented mess so that we can actually find what causes what. And also, regardless of what tools we are using, what activities has been done, we need to do software maintenance. So of course we need to also talk about what tools would enable you to do better work or easier work, or at least try to have a head start or fighting chance to keep your system afloat. There's a couple of things which could be mentioned also money-wise. On software products, up to 93% of product costs are reported in maintenance and development while in maintenance. If we consider, for example, short-time mobile games, they launch with minimal amount of content to test out if there's enough users. If they gain enough users, they might run for years. Clash of Clans is, I don't know, approaching a preschool age at this point. It still generates huge amount of money, of course. I'd venture a guess that the first original Angry Birds is still out there somewhere. And it means that someone has to maintain the product. So it generates costs. Of course, if your product generates billions of US dollars, these costs might not mean anything, but still someone has to pay for maintenance. And consider that you develop one mobile game in 6 months or so. If you are expecting to keep the game afloat, so you meaning that you add content, add support for new phone versions of, for example, new Androids or new Apple products, or add more levels so that your invested players can keep doing whatever they are doing, it means that you actually have to have a development team and pay salary for them. So this generates unexpectedly as much as 93% of all costs if we consider the life cycle, not just the first launch, but the life cycle of software product. There's also this rule of thumb, which I've seen on several angel investor sites or places where I've been able to talk with people who are involved in startup companies. So it costs €1 to come up with an idea and proof of concept. Compared that it costs €10 to test and develop a product out of that idea. But this is nothing, because those €11 you have spent, you still need €100 to maintain and commercially support the product, so that it's something that goes through its life cycle, has users, and has any possibility to generate money. So design costs €1. The first launch costs €10 and the software lifecycle is €100. So we are not talking about peanuts here. The main software maintenance isn't just fixing bugs now and then. If we are talking about real commercial software development, we need to hire more, sorry, not hire, but attract more customers or users. We need to keep our software system relevant, which of course means that we have to do constant development, and because most commercial software organizations are not charities, we need to be able to pay people for doing their work. So, considering all this, that we are talking about something like 90% of the life cycle costs for software, it's actually interesting that there's really few number of programs which do such course as this, which focuses only on software maintenance issues, tools, and products. Considering that, for example, the software development, I think most of you have taken at least 3-4 courses on that theory already, and in several places actually there's no separate software maintenance course whatsoever. So consider yourselves lucky ones because you are on a course which talks about the rest of the 90% of the software development. So, yeah, I've been talking over an hour now. So, granted, there is a software maintenance standardization. So, but who the hell uses these standardizations anyway? So, concepts are here. This is completely correct. But we are going to discuss more about what actually happens and how things are done. We saying that this standardization, which is already available on the course pages, it isn't wrong, but it's designed by committee. It gives you an overview on what the software maintenance in general is, but it doesn't actually answer on most of the problems, or why it's done, or how it's done, or what are the practical problems involved. Also, there's different types of maintenance. Corrective maintenance, adaptive maintenance, perfective maintenance, and preventive maintenance. There's also emergency maintenance, which is probably something that's currently being done on our university Moodle system. It means that something went belly up and we need to fix it as soon as possible. There's also additive maintenance, which is more or less increasing the amount of content, meaning that you add more movies, music, levels, whatever, or more things you can do. Or if we are adding more features for our users, it's also called perfective maintenance. And this is actually interesting because statistically, perfective maintenance is actually the most common type of software maintenance work. Of course, this is over 10 years of data. But this is the amount of studies made on this area are quite uncommon. So at least on 2008, just about at the age where mobile systems became ubiquitous, meaning that they are everywhere, the perfective maintenance is the most common type of maintenance work. So we add features so that we get more users, or add activities which we would have wanted to have on the product from the first day it was launched. The almost perverse part here is that the preventative maintenance is 4%. This means that we just try to make the tool better. We don't have to do it because it's broken or horribly in flames or something like that. We just want to fix some small issues, fix the code smells, the small problems which end up hindering the usability. Well, of course, no one does that. It costs money, and why should we spend money on anything if we ask from the marketing or business department? But anyway, considering that these sort of numbers give you an idea on what type of work is usually done on the maintenance cycles. And of course, it's not only the type of maintenance work, it's also how old your product is, because the life cycle of software isn't just same state all over their life cycle. There's actually program aging, meaning that when you introduce your product, you have emphasis on user support so that you can actually keep the people who decided to take your product. Then you try to grow, you correct faults, you reach maturity, you try to make enhancements, additions. Your competition is ahead of you. You copy or create a similar functionality or add features which keeps your product competitive. That's maturity. And finally, the decline. The cost of keeping up with competition or cost of using the same version of the product in modern platform is just too much. It would be easier or more cheaper to create the software from recreate it completely. So of course this means that your current product is in decline and there's a new product growing out from your existing work. But of course, if this is something that happens, you don't probably emphasize on correcting faults or making enhancements or additions or do user support in a product which is going away. So not only the type of maintenance are you trying to add content or fix problems or whatever, but what's the stage of your product also dictates what you most probably are going to try to do on your software cycles. Well, this was already covered. So whatever maintenance you are doing, the unstructured code, insufficient domain knowledge, and insufficient documentation are all problems which hinder the maintenance work most. So the documentation is the same as in software engineering. The unstructured code and insufficient domain knowledge are something that's not as familiar, perhaps, compared to original software engineering work, simply because this also involves time as a factor. There are periods during which your software product is probably not actively developed. People change, brain drain happens, someone leaves the company, or there's simply no reason to update the product before you find a new customer. Then you get a new customer and you have to scramble to find yourself a development team. So of course these also all mean that the domain knowledge deteriorates. And that's why, and this is something that's fairly common for software maintenance cycles. Okay, so there's a number of tools. We will be getting back to this. There's tools to counter most of these problems. Version history tools, gain insight on behavior, gain insight on structure, reformatting tools to get idea on how the code was written originally. And finally, this is a favorite list of mine, because this is something that we get back to several times during this course. So, indicators of system decay. Indicators that there's something wrong with our product, or that the product itself is old, it's getting out of date. It's something that no longer fulfills every requirement. The components become very large. There's a frequent failures. It's overly complex. It's running in emulation mode because we no longer have the hardware it originally ran on. There's no documentation. there's resource requirements which are completely crazy considering what the system is actually doing. There's high personnel turnover because no sane person wants to have anything to do with the project. And finally, it's a mismatching parts from here, there, different technologies, programming languages, patch upon patch upon patch upon patch. So basically, this all means that your system is decaying. It probably needs a large amount of maintenance work, or on some occasions a bullet to its head because it needs to be recreated. So, the problem with the software is that even though it's a static source code, unfortunately the world in which it works is not static. If someone uses your software, it needs to change at some point. Because you get new users who require new features or find something broken in your system, you will get competition which requires you to address their work somehow. The hardware changes, the software changes, the development environments change. So if you are running a professional software project, you need to address these issues. Even if you wrote a perfectly, completely, fully perfect code, which was done in a project which was under budget in time, with all the features you could ever ask for, and all the users super happy how it turned out, you still will see system decay when the world around your product moves on. This also means that you will have to do different types of maintenance work. You will have to focus on different types of aspects on the software maintenance, because you will want to attract new users. You will want to retain your existing user base. You will have competition. You will need to do some emergency work, because at some point you will have problems adapting to new hardware or new platform or whatever, meaning that it's inevitable evolution. Unless you own all the technical platforms and own everything, then you can say that, okay, we will not move onward from this, but because the world isn't in a hardcore communism, that will not happen. You will always have someone to compete against you or propose better solution at some point, and you will want to address your competition somehow. And like on the earlier courses, the unstructured code, insufficient knowledge, insufficient documentation, and bad image of maintenance work. You are put to do the software maintenance because you are too unskilled to actually do the lead development work. These are things that usually hinder the software maintenance work. So, what should you remember from this first lecture? First of all, there's a life cycle. Why do we need to do maintenance? It could help you if you can answer to yourself. Why should I know any of these things that are going to be talked on this course? The first exercises, weekly exercises, will be available next week. If Uni still says that there are exercise groups, well, there aren't. You can send an email or send a message to the Moodle discussions. Go check that you have access to Moodle pages by the weekend. I will send an email when everyone should be able to access the site, but if there are some problems, I can try to help individual students. But I think that there's a larger technical problem because there were only 5 students on the Moodle pages this morning. So something went belly up. Hopefully they'll fix it as soon as possible. Get yourself a project group. When you get access to Moodle pages, read the instructions and reserve your project topic. 3 members is the hard maximum because the projects are designed so that they scale a bit the project groups, but more than 3 means that the 4th one is the first freeloader, so I'm not going to add that person. And when you have your team, start doing the project works. Okay, so this is the first lecture, 9 to go. So do you have anything to ask, want to comment on things, stuff like that? If the recording works, it will be available in a few days' time from the Moodle pages. If it fails, then you will get the 2019 version of the lecture, but you will get the 2020 slide set anyway. And when we start doing the weekly exercises, when you walk out of the lecture hall, they are available, and they are available until the start of the next lecture. And both projects are already online, and the exam will be added at the latter part of the 4th period, meaning it's April-May timescale. Good? Excellent. So let's stop.